My name is Paul Nussbaum, and welcome to the demonstration and instructions for the INTEGRAT software program. Why is INTEGRAT important? It used to be that only human experts examined data and made decisions. Now artificial intelligence is enabling robot decision making in an ever-widening variety of applications. As society allows this to happen, there's a greater likelihood that these robot decisions can affect people's lives. It makes sense, therefore, to understand the capabilities and societal implications of these AI robots. Big data is a term used to describe both opportunities and problems associated with so much information now available for decision making. With the advent of the Internet of Things, the IoT, the impact of this huge amount of data is only growing. Actionable decisions need to be distilled from big data, and AI can only go so far based on linear extrapolation. Because of this, many non-linear deep learning algorithms are being developed. So what exactly have these AI robots learned so deeply from all of this big data? The question is actually very reasonable for society to ask. It's not enough to train and create a great AI robot. Many researchers are realizing that before their systems can be deployed, they must be able to prove to human experts that the robots learn the right things from the right data. This is difficult because human expert decision makers are not necessarily the same people who are good at creating robot AI. These two teams must work together in a user-friendly way. If only we could read the robot mind. INTEGRAT was covered by 4 US patents, but they've now expired. So recently, some old research of mine has been getting increased attention by engineers and scientists working on exactly those issues I described. This research yielded 4 US patents and a Windows application that gives a friendly user interface to allow examination of big data and the inner workings of a trained AI decision maker. I never publicly released the software, called INTEGRAT, because I sold the rights to the patents to my employer at the time. Now that those patents have expired, I can share my work as well as the software specifically designed to read the mind of the robot. To make this research more easily accessible, I'm releasing the software for Windows, this short YouTube video explaining how to use it, and also the source code is all on GitHub, and there's the URL address right below. What does INTEGRAT do? Well, if you can speak and understand human speech, then you're basically an expert phoneme recognizer. If you could not tell the difference between phonemes, you wouldn't be able to understand human speech. So for this reason, INTEGRAT focuses on phoneme recognition. So unlike biomedical signal analysis or stock market analysis or any other number of AI applications, INTEGRAT lets the robot developer also act as the subject matter expert. INTEGRAT lets the user develop a complete AI robot to recognize phonemes. INTEGRAT also lets users read the mind of the robot and check that the robot learned the right things from the right data. Here you can see the opening screen of the INTEGRAT program running under the Windows 10 operating system. To begin, we load an audio file containing phoneme examples. These are going to be used to train the AI robot. The sample file, ooaee.wave, is included with the INTEGRAT source code. This audio
UAE.
file has a single person speaking aloud 4 simple vowel phonemes, oo, ah, e, and e. Before data can be used for training or testing, it has to be divided into segments that can be individually identified. Here, automated segmentation parameters can be configured. Segments can also be manually added by clicking in the green area. Once the segments have been created, each segment can be identified by the human expert. The human expert can examine segments one by one. In this case, segments can be examined visually and audibly. Segments can be removed by clicking in the blue area. If a segment is deemed to be less than optimal, it can simply be omitted from the training set. Here we see the human expert has deleted several segments. Only the best segments have been kept for the training set. The human expert is now asked to make an estimate of the number of different phonemes that AI robot is going to encounter. The number of possible identifications is going to help us dimension that AI system. In this simple example, there's only 4 different phonemes. One by one, the human expert assigns each data segment to an identification number. Each identification number can also optionally be assigned a short name. The short name doesn't need to be entered every time. The identification number is sufficient. As the human expert identifies the segments, they can also inspect them visually and audibly. If a short name was provided, it appears right underneath the segment. Now that the raw data has been segmented, it must be converted into a set of features. This transformation process is often very specific to the type of data and to the type of application. But in all cases, a good quality feature set can be extremely important. INTEGRAT allows the transformation process to be turned on or off. And at first it asks whether linear predictive coding, or LPC, is going to be used as the transformation method for feature extraction. In this case, the user has skipped over LPC and is going to use fast Fourier transform, FFT, as the feature extraction transformation algorithm. Most transformation algorithms require additional parameters to be entered. Here, the FFT transform algorithm, parameters are being selected: frame size, overlap, interval, as well as the resulting number of dimensions. Below each segment are one or more vertical columns that now appear, showing the features that we extracted using that transformation algorithm. In this case, the features represent vocal cord harmonics modulated by the mouth and the tongue. The human expert can visually see that the feature vectors from the same group of identified data look similar to one another, and it looks different from those from different identified data. So that means, visually at least, it seems to represent a pretty good data set. As per one of the patents granted for the software, INTEGRAT also performs an untransformation to see if the feature vector contains sufficient information for a human expert to tell the difference between different identified segments and still make the correct identification. In the case of INTEGRAT, the untransform also provides an audio recreation of the vectors. At this point, the user may wish to start saving the training set. INTEGRAT offers this information archival. These con, TRA, and COD file suffixes are automatically added by INTEGRAT. The user only needs to select a valid Windows file name, such as the word test, and then click Save. The data is automatically saved to disk, although there's still no training or coding information to save, because we haven't completed those yet. If the human expert is satisfied with the segments, their identification, and the transformation, then this group of segments could be added to the training set. Now that they're added, INTEGRAT presents a complete summary of all the configured parameters in the data. Notice that the number of examples for each of those IDs is the same, 14 of them. This can be important for unsupervised learning, where the AI robot learns not only the different IDs, but also the likelihood of each. Since the human expert has added to the training set, the information should be archived to disk. This can be repeated over and over, and more data segments are added to the training set. The previous file names are going to be used again unless you explicitly change. The configuration settings are saved in a very small file. And now the training data is also going to be saved. We still don't have any COD coding file results. So now comes time to use the training data to create the AI robot. INTEGRAT calls this step the code step. The INTEGRAT AI robot is going to attempt to examine each feature vector and identify it with a code based on the training. So INTEGRAT allows the coding functionality to be turned on or off. INTEGRAT also offers 4 different kinds of coding. 2 of them are unsupervised, UCL and auto-associative neural networks. And unsupervised coding ignore the human experts manually entered correct ID values, and instead they simply look for patterns. The other 2 kinds of coding are supervised, SCL and backpropagation neural networks, and they try and learn the correct ID numbers. Here the user has selected SCL coding. Both SCL and UCL slowly train to find an optimal centroid of the data provided. The neural networks, on the other hand, adjust connection weights to slowly minimize an error value over repeated training. Once the coding has been selected, training can begin. INTEGRAT divides training into passes, which are a fixed number of training iterations presenting random entries from the total set of vectors in the training set. So here we see that a training pass is underway. So far it's presented 900 randomly selected training vectors. Below the segment vectors, we can see the robot's internal exemplary vectors for each ID. Each of these 4 wide column vectors should look similar to the vectors of the IDs that they represent. Here, a complete single training iteration is finished. 2,800 randomly selected training vectors were presented. The green horizontal bars represent the number of times the AI identified each ID, and the number of times each ID was presented for training, respectively. The green bars are pretty much the same brightness all the way across, since we had pretty much an equal number of training examples for each ID, and that's what we would expect. As per another of the patents for the INTEGRAT software program, INTEGRAT attempts to identify these exemplary vectors for each ID by examining the internals of the AI robot's mind. And that's going to be different depending on the coding algorithm. We call this decoding, and in the case of phonemes, it can also be converted into audio. By using decoding to read the robot's mind, the human expert can see and hear what the robot imagines a phoneme vector should look and sound like. Additional training passes can be conducted to improve the AI robot performance, although excessive training can sometimes backfire, causing the AI robot to learn only the training set and not be able to handle real-world variations. Once the human expert has determined that the training is yielding sufficiently good quality results, the entire work can be saved. Notice that now, in addition to the configuration and training files, there's also coding information. And that's basically the trained AI robot's brain, if you'll forgive the personification analogy that I've been using. So all of that can be saved in the individual files. As per another of the patents granted for the software, INTEGRAT allows the human expert to observe how the trained AI robot behaves under conditions that it was never trained for. So in this case, we want to load that data that was not available in the training set and then test how the robot is going to work in fully automated mode to identify and make decisions about this new data.
Why?
So here, a human expert chooses a different audio file. This one contains all 4 phonemes spoken very quickly as if they were part of one word. In the case of phonemes, the harmonics created by the shape of the mouth are no longer going to be stationary, but they're going to be moving and changing continuously. As can be seen from the above, the AI robot did a pretty good job of identifying at least the correct sequence order of the phonemes spoken. Notice how the vocal cord harmonics are continuously moving, gliding from one phoneme to the other, as the mouth and tongue move from one position to the next without stopping for very long at all. As can be seen from the green horizontal bar near the bottom, the last segment was identified as being mostly ID number 4, eh, but in some small way it resembled ID number 3, e phoneme. So not shown here, but as per another US patent, INTEGRAT allows the human expert to assign multiple possible correct IDs for segments that might be ambiguous. So this concludes the INTEGRAT software demonstration and instructions. And I'm hoping that these methods and this software apparatus is going to help improve the understanding by individuals and society of the capabilities and societal implications of these intelligent systems. Best regards to all of you, and thank you for watching.